right, we're going to talk about Euler's number. Euler was a Swiss mathematician, and he lived from 1707 to 1783. He's really one of the greatest mathematicians of all time. And pretty often I just say E. So E is an irrational number. And when I write equals here, I don't mean, I'm going to put a dot, dot, dot to show that I cannot express it as this number right here. This is a rational number. I can express that as a fraction. Irrational means it keeps going on forever without a pattern. And so E is an irrational number. There is so much that goes on with this number and why it's important, but without calculus, we can't really give it justice, or without using some calculus. But I wanted to introduce this number because it's so important, and to take away some of the mysteries. It is a number between 2 and 3, and so especially I want to look at the graph of y equals e to the x. Well, the graph of e to the x looks a lot like the graph of 2 to the x, a whole lot. So pretty often, if someone is presented with a problem and they're supposed to sketch the graph, like on a test or something, just replace e by 2 to get the rough sense of what the graph is. I mean, it's not exactly the same, but look, we have, as we see, it's increasing. It has a horizontal asymptote to the x-axis. It has the has an intercept, y-intercept of 1. Because what? Why is that? E to the 0 power is 1. E is positive. It's going to be increasing. If I were just sketching graphs by hand, I would want to use base 2. But base 2 doesn't do the job. This function is the only function where if you said that this is the displacement of a moving particle, if that's a function for the position of a moving particle, if this is the position of a moving particle, and you wanted to find the velocity by that particle, it would have the same function. And that's why it's very important. It has to do with rate of change and velocity, and that it's the function where the rate of change of that function is the same as itself. And it's the only function that has that property up to multiplying by a constant. Like if you multiply by 5, it would still have that property where the rate of change of the function is equal to the function itself. Okay, so here's, y equals e to the negative x. It looks a lot like y equals 2 to the minus x. But this is just, the star of the show for math, engineering, finance, everything. So we're going to use base e, but base 2 is a nice function because it's easier to sketch the graph and it's easier to explain the exponential idea of doubling.